Okay, guys, so what we're going to talk about today is coterminal angles and reference angles, two things that are very, very, very important for the rest of this unit, okay? So we're going to start off with coterminal angles. Now, we said coterminal angles were angles that shared a terminal ray and generally started in standard position, okay? So shared an initial ray, share a terminal ray, but they don't have the same measure, okay? So let's look at the first one. We have 90 degrees, right? 90 degrees, we know is a simple one. Here's 90 degrees. You okay with that? If it's in standard position, what does that mean? This is a vocab word. What's along the x-axis? Not the terminal, the initial ray. Initial ray is along the x-axis with the vertex at the origin. I shouldn't use blue. I guess it looks like my lines here. Okay, so here's my initial ray. Here's my terminal ray. And what else do I need to show? Good, my direction of rotation, right? So here's my direction of rotation, and I'm at 90 degrees. I want a coterminal angle. Now, we have a couple of different options. I can have a positive coterminal angle. I can have a negative coterminal angle. For these ones, we want to find negative, but we need to talk about how to find both, okay? And it's actually really simple, because all coterminal angles are is adding or subtracting multiples of 360 degrees, okay? So a negative coterminal angle, again, has to share the initial and has to share the terminal. So instead of going counterclockwise, I'm going to go clockwise, right? So here's my coterminal angle going in this direction. How many degrees is that? Good, that's 270 degrees, right? 270 degrees, but it's, what direction did I go? Clockwise, so it's negative 270 degrees. So that's one way to find a coterminal angle. How could I find that algebraically? Awesome, okay? So 90 minus 360 would give me negative 270. Okay, so that's how I could find it algebraically. I could subtract 360. What if I wanted a positive coterminal angle? What could I do? I could add 360. Good. So another coterminal angle, I could start here, and I could go around once, and then again, and stop at my terminal. So that one would be 90 plus 360, which would be 450. Both are coterminal angles. So all I did to get a coterminal was what? I could either add 360 or subtract 360. Now, if I want a negative coterminal angle, I'm going to do what? Subtract. Now, can I only add 360 once to get a coterminal? No, I can add 360 as many times as I want. They're still going to be coterminal angles. They're still going to start and end in the same place. It's just going to be more rotations. Are we okay with that? Okay, so what we're going to do is I want you guys to practice these. You're going to draw the rotation diagram for B, C, and D, and you're going to find a negative coterminal angle algebraically, okay? So go ahead and try those. I'm going to pause, and we'll come back and go over them in a minute. Okay, so negative coterminal to 330, all we have to do is do 330 minus 360, which gives us negative 30. Good. How many of you got that one right? Awesome. Yep, that's fine. Yeah, 330 would be about here, right? Agreed? So here's negative coterminal, negative 30. Okay, 120 is going to be about here. Agreed? Negative coterminal would look like this. And we're doing 120 minus 360, which gives us what? Negative 240. Very good. Doing okay? 210. It's going to be about here. So negative coterminal is going to look like this. 210 minus 360 gives us what? Speak up. Negative 150. Good. Okay, so we good with coterminal? So literally, all you're doing is adding or subtracting 360s or multiples of 360. Got it? Awesome. Same way. Add or subtract 360. Still the same thing. You're just adding or subtracting 360. If you wanted a negative and it was over 360, like say you had 410, and I want, 410 has a 1 in it, doesn't it? Okay, and I wanted a negative coterminal, then I would subtract 360 degrees twice. That would give me a negative value and it'd still be coterminal. Okay? How would I leave? Twice. Yeah. Ready? Okay. Let's talk about, okay, coterminal angles drawn in standard position will always have measures that differ by an integer multiple of. Yeah. Good. Okay, that's what we have been talking about. Okay. I'm sorry. Oops. All right, so let's talk about reference angles. Reference angles are going to be incredibly important for the next couple of units. Okay, you guys have to know how to find reference angles. What's a reference angle? If you have to go back to page 1 to tell me the definition, do so. What's a reference angle? Yeah, the angle made between the terminal ray and the closest x-axis. What is it always less than? 90 degrees. Okay, reference angles are always less than 90 degrees. Now, we have some rules that go along with reference angles. Okay, and if you didn't already write them down, you need to write them down. Are you guys ready? So you're going to draw this in your notebooks. Okay, so when we're dealing with reference angles, we have some rules that allow us to find the reference angle of an angle very quickly. Okay, if the angle is drawn in standard position, and it's a positive angle, we have 4 rules, okay? If the angle's in the first quadrant, the reference angle is simply itself. It's less than 90 degrees, it's itself, okay? In the second quadrant, to find the reference angle, we're going to do 180 minus theta. In the third quadrant, it's going to be theta minus 180. And in the fourth quadrant, it's going to be 360 minus theta. Okay, so if you have a positive angle that's less than 360 degrees, these rules will help you to find the reference angles. Okay, sometimes you just have to think logically. Like when we talk about negative rotations, these rules aren't going to be right because everything's upside down. We're rotating in the other direction. Okay, so you have to kind of pay attention to what you're doing. So what the first one was what? Beta equals 160 degrees. Oops. Okay, so here's what you're going to do. First thing first, we draw the rotation diagram. 160 degrees, the terminal ray lies in what quadrant? 160. Where does the terminal ray lie? Second quadrant, yeah, because we know this is 180, 160 is a little bit less. So if it's drawn in standard position, meaning the initial ray is along the x-axis and the vertex is at the origin, 160 degrees, we could say it's about here with the angle of rotation, 160. Okay, so there's the rotation diagram. The reference angle is this angle right here, terminal ray closest x-axis. Now, you can use the rules, or you can think logically. You know that half of a rotation is 180 degrees. You agree? So if I've gone 160 degrees, how much more would I have to go to get 180? 20, right? That's logic. You guys can do that in your head. You know what it is, okay? You need 20 more degrees to get to 180 degrees. You can use the rule, 180 minus 160, which gives us 20. That's going to work too, okay? But sometimes you need to use logic. Use your brains, okay? All right, what was the next one, guys? 300? Okay, so I want you to draw the rotation diagram, draw in where your reference angle is, and then find what it is. Okay, remember, if you wind up with an angle, a reference angle that's greater than 90 degrees, you've done something wrong. Okay, So go ahead and try 300, and we'll go over it in just a second. All right, so 300 degrees, what quadrant? Fourth, good. So we're talking about here. Here's your rotation, 330. Where's your reference angle? Whoops. Where'd it go? There it is. So it's right here. 300, sorry, did I write 330? I did. I don't know why. Okay. So there's that little piece. Now, if I've gone 300 degrees, how many more would I have to go? 60. So that's like using your head, right? The rule for that, 360 minus 300 gives me 60 degrees. We okay? Awesome. All right. So I want you to go ahead and try CD. Well, do CD. We'll talk about E in a moment, okay? All right, 210 and 78. All right, 210. What quadrant does it terminate in? Third quadrant. So 210. Here's my angle. Where's my reference angle? Left or right? On the left, right? So here's my reference angle. Now, logically, I've gone 180 degrees from here to here, right? How many more would I have to go to get to 210? 30 degrees. Good. So there's your logic piece, right? Algebraically, 210 minus 180 gives us 30. Good? Any problems? Awesome. All right. 78 degrees. What quadrant? First quadrant. Okay. What do we know about it? Yeah, it's itself. It's its own reference angle, right? It's less than 90 degrees, terminates in the first quadrant. The reference angle is 78. We good? Awesome. Okay, so let's talk about a negative one. The next example was, I don't remember. Help me out. I'm sorry, honey? Negative 110. What is going on with me today? Okay, so negative rotation, clockwise, counterclockwise? Clockwise. Initial position starts along the x-axis, vertex at the origin. Negative 110 degrees would terminate in what quadrant? Third, yeah. So here's negative 90, negative 110, maybe about here, in this direction. Okay. Reference angles. Can they be negative? No, they have to be positive and less than 90 degrees. Okay. Where would my reference angle be? Yeah, on the left, right here. There's my reference angle. So two ways we can do this. We can think logically, right? I know that halfway around from here to here is how many degrees? 180. I've gone 110. How many more would I need to go to get to 180? 70. There's your reference angle. Are we okay with that? So the other way we would do this is you kind of have to think backwards. What we've done when we go in a negative direction is we've essentially flipped everything upside down, right? So this becomes our reference angle. This becomes, everything goes down, okay? So algebraically, what you would wind up doing is you would be doing 180 minus the absolute value of the angle, okay? 180 minus the absolute value of negative 110 is positive 110, which is 70. So everything kind of gets upside down and we throw in that absolute value. Okay? So if you were here in the second quadrant, your rule would come up here with you. The absolute value of the angle minus 180. Okay, so we're kind of working backwards. What's the next one? Beta equals what? Negative 280. Okay, so go ahead and try that one. I'm going to go over it in a second. Okay, so negative 280 falls in what quadrant? Yep, first quadrant. All right, 270, 280. It's going this way. Where's my reference angle? Yeah, to the right. All right, we need this. So we can think logically. If I've gone 280 degrees, how many more to get to 360? 80. What's the other way we can do this? The absolute value of negative 280, which gives us 80 degrees. How do you guys feel? Not bad? Okay. All right, so we have, whoop, that didn't work, did it? 605 and negative 410. So let's look at 605 together, and then you could try negative 410. All right, guys, 605, 605 degrees. So let's think about our rotation again, all right? We go 0, 90, 180, 270, 360, 450, 540, 630, right? Multiples of 90. Okay, so where is 605 degrees going to go? Good. Somewhere in this third quadrant, and I know that I'm going to go around one whole time and then some. Okay? So my reference angle is right here. We just need to figure out how to get it. So is this rule of subtracting 180 going to work for us? No, why not? I went around one whole time and then some, right? So what do I need to do to 605 before I can subtract 180? Good, I got to take out that one full rotation so that essentially what it's giving me is this. Okay, that's what I want. So I'm going to take out that one full rotation, which is going to give me a value of what? Okay, so now there's the angle I want to use when I use my rule. 245 minus 180 equals, I'm not doing it for you guys, 65, yep. There's your reference angle. Okay, so if it's larger than 360 or smaller than negative 360, okay, you have to take out that one complete rotation so that you can then find the reference angle. All right, so the next one is what? I'm sorry? So go ahead and try that one. Okay, so negative 410, again, starting in standard position. We go all the way around once, and then we're going where? What quadrant am I going to end in? Fourth quadrant. 410, this would be 450, negative 450 here, so about here. Okay, what's my first step? Yeah, let's take out a factor of 360, so negative 410 plus 360 is going to make that work for me. Okay, what do we get? 50. Okay, what do you know about 50? It's less than 90, so it's the reference angle, 50 degrees. Okay, it gave it to us, 50 degrees. Okay, how do you guys feel about reference angles? Your homework is pages 4 and 5. Number 2, where you made all of those rotation diagrams and you labeled where the reference angle would be. Now you're going to find all of those reference angles, and then the rest of page 4. Okay. Tomorrow we will finish the lesson, and you guys have 10 minutes at the beginning of class. You have to take that vocab quiz. 10 minutes, no more. It's going to be very simple. You write the definition, you draw the picture, you label it. Okay. Lots of labeling involved. Your pictures better be correct. Any questions, guys? Am I going to what? Nope. You got to just, yep, exactly.